Hello everyone, this project is SQL query parser. It takes a SQL query and processes it in stages. First the lexer, then parser, then semantic analyzer. I'll be explaining the lexer part, which is the first stage. Its job is to take raw SQL text and break it into tokens. The lexer folder has four files: tokens.py, and this file defines what a token actually is. Here we have a list of every token type, keywords, identifiers, numbers, and so on. There's also a dictionary of SQL keywords like select, where, join, and there's the token itself. It stores the type, value, and the line and column where it was found in the source code. Next file, which is regexpatterns.py. This file has the actual regular expressions used to match each token. For example, float numbers are checked before integers, so something like 1.5 does not get split wrong. And here's the important function. It tries every pattern at the current position and picks whichever one matches the longest text. That's how Alexa decided what counts as one token. And moving on to dfa.py, this file builds the finite automaton logic, converting a regular expression into NFA. Then that NFA is turned into a DFA. This part is not used directly for scanning the text. It's there to show the automaton theory behind how matching actually works. And then finally, it moves to lexer.py. This is the main file that actually runs everything. The three functions and the three files are important here. And here's the tokenized function. It loops through the input until it's done and collects all the token. And there's a function that gets the next token, which skips white spaces, then find the longest matching pattern and turns into a token. And a part of the code is checking if the word is actually a keyword like select, from, and mark it as a keyword instead of a normal identifier. So overall, the SQL text goes in, it gets scanned character by character, matches against the pattern, and comes out at a clean list of tokens ready to be passed to the parser. Now I would like to call the next presenter.
I will be talking about the parser part of the code. So once the lecture breaks SQL into tokens, the parser checks if they form a valid statement and builds a parse tree out of them. Basically, there are three files: grammar.py, lr1parser.py, and parsetree.py. Starting off with grammar.py, it is the rule book. It defines terminals and non-terminals and rules for how they combine. Line 415 is a good example and expression that is either two expressions joined by or just a similar smaller one on its own, which is how nesting works. The rest of the file is more rules like that, covering select, insert, update, and so on. And next file is lr1parser.py. It is actual engine using lr1 parsing. It first builds all the possible parser states using closure and goto and turns those into a parsing table. Then parse reads tokens one at a time, and based on that table, either saves a token onto a stack or reduces a group of tokens into a tree node, repeating until the input collapses into a full parse tree. If a token doesn't fit, it skips ahead to a safe point like a semicolon instead of crashing. Now moving on to next file, parsetree.py, it holds the result. Each parse node stores what piece of query it is, its value, and its children. So the tree mirrors the SQL statement structure. It also has a visualize method to print it out neatly. So the grammar defines what's allowed. The L1 parser checks the input against it and builds the tree, and parse tree defines what the tree looks like. Now moving on, I like to go next presenter.
Okay, so talking about semantic analysis. So I'll be talking about the semantic analysis where the symbol tree, type saver, and attribute evaluator is there. So first on the symbol table. So what happens before is that the first before checking if code is correct or not, the compiler needs to know what exists, and that's the job of the symbol table here. So what is has these a data type enum and the symbol class and also the scope class. And then looking at the symbol table class, we is that it wraps up everything together. So there are three things to highlight here: enter scope and exit scope, which pushes and popped up scopes and use when we enter or exit of subquery. and a defined table there is which register the schemas info as you pass, and as well as you can see maybe there's a init SQL function which is pre-registers a built-in function like count, sum, upper, or so the type checker recognize them immediately. So in short, the simple table is nested dictionary of path value right now with parent child links for scope. So now talking about type checker. So talking about the type checker.py, so it has what is exists is that we need to check if the operation are legal or not. So that's what this code of the function does. So we have first we have the operator enum, which checks up the we defined all the SQL operators grouped into arithmetic, comparison, and logic categories. Then the function rows dictionary, which checks the which checks that this table is defined the type promotion, for example, like integer or floats, which promotes to the floats. So and then next there is I think check automatic operation. So which is the method which checks the automatic operator against the promotion table. And and lastly, there are more of them like check comparison operator or check logical operator and check all function calls. And finally, so what this kind of code does is that it checks off, it is check method answer one question where it is the is this combination of types legal, and if so, what type do we get back? And then now moving on to attribute evaluation.py. So finally, this file is orchestrator here. So it ties the symbol table and type checker together and works the pass tree now. So we have here, I think it's called attribute classes which models the attribute grammar theory, and attribute evaluator classes, which is the main engine here. So a few key methods here to include is that it check column reference in the function where it verifies the column actually exists in the table. So using a symbol tree, and evaluation function we call function is delegates to the type checker. And also there are many evaluate type correction which checks the implicit conversion like integer, silently, and becoming float. And more on there are semantic rules and semantic rules which instead of hardcoding if statement everywhere, we have implemented and defined it as a semantic rule declarability here. So having the clause requires by like root by or where clause must evaluate the boolean. So this is a cleaner and easier part of code. And just then now as a final, I think there's a semantic analyzer class, which is actually what gets called from the outside. So it analyzes the runs the pipeline, full pipeline, and builds the type map, collects the error, and return true or false along with a list of semantic error. So finally, to summarize, we have built a symbol table, type checker, and attribute evaluator. So now I want to call next presenter here.
Hello, sir. So I'll walk you through our error handling module and how it supports our LR1 SQL parser. At a high level, the module is responsible for collecting and formatting all problems that occur while compiling an SQL query, from bad characters detected by the lexer to grammar errors from the parser to semantic problems like type or name errors. The module has three main pieces to know. First, error severity is a small enum that standardizes how we label problems such as lexical, syntax, semantic, warning, and info. Using an enum keeps the rest of the code simple and unambiguous when we summarize or filter errors. Second, error entry is a compact data class representing one problem message line and columns, severity, and optional metadata like suggestions. We use this structured record because it makes formatting and grouping straightforward for the output. Third, the error handler is the central component. The parser, lexer, and semantic analyzer can call methods on this object when they discover issues. For example, the lexer should call lexical error function if it finds an unexpected character. The parser calls syntax error when a production fails or an unexpected token appears. It can also pass what tokens were expected for clearer feedback. The semantic analyzer calls semantic error when it finds a type mismatch or missing symbol and can add an optional suggestion for how to fix it. The error handler stores error and warnings separately, keeps counter, and exposes utility methods. For the final printed report, get error summary functions to get counts by type, has error function to check quickly, and should stop function to enforce a max errors cutoff so we don't get flooded with repeated errors. You might also notice a sync token set defines on the handlers. This is a shared list of SQL keywords and punctuations that the parser can consult when implementing panic mode recovery after a syntax error. The parser can skip tokens until it reaches a token that is safe to resume from. There's also a SQL error class here, a typed exception. The code base can raise this when it needs an immediate exceptional abort path. Meanwhile, the handler's recorded error entry mechanism supports aggregated reporting for non-fatal problems. So that's all from my side. Now I'd like to call the next presenter.
Hello, sir. I will be giving the demonstration of our project. हाम्रो प्रोजेक्टको डेमोन्स्ट्रेसन चाहिँ 3 फेजमा छ। हामीले फर्स्टमा चाहिँ एउटा टेस्ट सुट डट पाई भन्ने एउटा फाइल डिफाइन गरेको छौँ र त्यहाँ चाहिँ हामीले भेरियस भ्यालिड क्वेरिजहरू राखिरहेछौँ एन्ड इनभ्यालिड क्वेरिजहरू पनि छ अनि सर्टेन एज केसेसहरू पनि छ। त्यसमा चाहिँ हामीले हाम्रो कम्पाइलरलाई चाहिँ टेस्ट गर्नलाई छोडिरहेको छौँ र यो भ्यालिड क्वेरिजहरूको एउटा इक्जाम्पल लिँदाखेरि चाहिँ सपोज सेलेक्ट एस्ट्रिक फ्रम युजर्स, यो त एउटा भ्यालिड सिन्ट्याक्स हो नि त, अनि यसले चाहिँ सिम्पल एउटा सेलेक्ट क्वेरी हो भनेर चाहिँ हाम्रो भ्यालिड क्वेरीलाई चाहिँ पास गरेको छ। एन्ड देन इनभ्यालिड क्वेरिजहरू हेर्दाखेरि चाहिँ अब सपोज हामीले यो फ्रम युजर्स भन्ने क्वेरीलाई चाहिँ रन गरेको थियौँ र यो फ्रम क्वेरिजमा त एउटा सेलेक्ट भन्ने किवर्ड नै मिसिङ छ नि त, अनि त्यही भएर यसले चाहिँ डिटेक्ट गरेर मिसिङ सेलेक्ट भनेर चाहिँ हामीलाई आउटपुट दिएको छ। एन्ड देन हामीले एज केसेसहरूमा पनि हाम्रो क्वेरिजहरूलाई हाम्रो कम्पाइलरलाई चाहिँ रन गरिरहेको थियौँ। अब सपोज यो हेर्दाखेरि चाहिँ सेलेक्ट एस्ट्रिक फ्रम युजर्स, अब यसमा त कुनै पनि कन्डिसनहरू त दिएको छैन नि त चेक गर्नको लागि, सो यो पनि हाम्रो टेस्ट पास भएको छ। एन्ड देन हाम्रो अर्को चाहिँ एउटा पास ट्री भिजुअलाइज गर्नको लागि चाहिँ हामीले एउटा डेमोन्स्ट्रेसन गराएको थियौँ र यो अहिले चाहिँ हामीले सेलेक्ट एस्ट्रिक फ्रम युजर वेयर आइडी इज इक्वल टु 1 भन्ने यो क्वेरीलाई चाहिँ हामीले पास ट्री भिजुअलाइजेसन गरिरहेको छौँ र यो कमान्ड चलाएर हेर्दाखेरि चाहिँ हाम्रो एउटा एचटिएमएलमा चाहिँ पास ट्री बनेको छ। अब यसलाई भिजुअलाइज गर्दाखेरि चाहिँ फर्स्टमा हाम्रो एसक्युएल स्टेटमेन्ट पास भयो हाम्रो कम्पाइलरबाट, एन्ड देन त्यसले सेलेक्ट स्टेटमेन्ट डिटेक्ट गर्यो, एन्ड देन टेबलको रिफरेन्स लिएर आइडेन्टिफायरहरू चेक गर्यो, एन्ड देन यो कम्प्लिट पास ट्री चाहिँ हाम्रो बनाइरहेको छ। एन्ड देन नेक्स्ट चाहिँ हामीले एउटा इन्टरेक्टिभ सिमुलेटर बनाएको छौँ। युजरले कुनै पनि क्वेरी दिएर चाहिँ चेक गर्नु मिल्छ लाइक भ्यालिड छ कि छैन भनेर। अब यसलाई टेस्ट गर्दाखेरि चाहिँ मैले एउटा एसक्युएल क्वेरी हान्छु, select asterisk from users where id is equal to 1। यो चाहिँ एउटा भ्यालिड सिन्ट्याक्स हो अर भ्यालिड क्वेरी हो। सो यो चाहिँ हाम्रो कम्पाइलरले डिटेक्ट गरेर भ्यालिड एसक्युएल भनेर चाहिँ हाम्रो क्वेरीलाई एक्सेप्ट गरेको छ र मैले एउटा इनभ्यालिड क्वेरी दिएर ट्राई गर्छु है त। यो चाहिँ हाम्रो एउटा इनभ्यालिड क्वेरी हो किनभने हामीले यो आइडी पछि इक्वल्स चाहिँ मिसिङ गरिरहेको थियौँ र हाम्रो कम्पाइलरले चाहिँ डिटेक्ट गरेर इनभ्यालिड एसक्युएल भनेर चाहिँ हामीलाई प्रम्प्ट दिएको छ। सो थ्याङ्क यू।